Yes, this is Unit 1, Lesson 2, Solving Systems of Linear Equations. What this is about is you get two equations, and just like we followed up from the very first one in the previous lesson, what you did there is you learned how to solve one equation for an unknown. Using those techniques, you can use this to solve the two equations and find the answer to where the two lines will cross each other. So that said, let's go ahead and get started. One thing is, let me remind you, if you've got any kind of questions, write it on your notes, bring it to class tomorrow, and ask it before we start, either by raising your hand and asking, or by writing it down on a post-it and putting it on the parking lot. Okay, here we go. Okay, definitions and such, what we have here is this. A system of linear equations that we're going to use here consists of two linear equations whose graphs, which are lines, generally intersect. Okay, the xy point of intersection is considered the solution of the system. What this means is that both equations will have this as a solution. So it means that each equation will be true at this one point. Okay, if the system intersects at more than one point, in other words, if the two lines are intersecting at more than one point, then the lines are the same line. Okay, if it intersects at no point, there is no solution. And the only way that's going to happen in a two-dimensional system like what we're talking about here would be if the two lines are parallel. Okay, we will consider two techniques for solving such a system in this lesson. There is a third technique which is called graphing, but it's usually more difficult to determine what the actual solution is because you're guessing in a lot of cases. Okay, so in this time we're going to consider two techniques. One of them is called the elimination method, which is sometimes called the addition method because actually you're going to add the two equations together to solve for one of the variables. Okay, the substitution method, you're going to take whatever one of the variables is equal to and plug it back into the other equation. Okay, in this case you will have a variable expression that you will plug back into the other equation for the variable. Okay, so example 1, using the elimination method, they want us to solve this system of equations, and the two equations are negative 2x plus 3y equals 11 and 2x plus y equals 1. Okay, so in this case, if you notice, the two x's have opposite signs and they have the same magnitude or a distance from 0. So this means that if we just line one up under the other, they will eliminate each other or make the x's disappear in this case. So the first equation is negative 2x plus 3y equals 11. Second equation is 2x plus y equals 1. So we just add them straight down the columns, and that will give us this following result, which is 4y equals 12. Since the negative 2x and positive 2x add together to give us 0, then it just disappeared out of the system or was eliminated. Okay, so we solved the 4y equals 12 by dividing both sides by 4, gives us y equals 3. So there's part of our solution. Now we take the 3, plug it back into one of the two original equations and for the y, and then we're going to solve for x this way. So we're going to take the 2x plus y, so that becomes 2x plus 3 equals 1. Subtract the 3 from both sides, gives us 2x equals negative 2. So x is equal to negative 1. So the solution here is going to be parentheses negative 1 comma 3 because it's a coordinate, and that simply designates a particular point where these two lines actually cross. Okay, example 2, they want us to solve this system using the elimination method. So let's see what we got. This is a little bit more complex because as you notice, they don't just have something that's going to eliminate just by lining them up like we did the last one. So in this case, we have a 2x here, and the thing we want to look for in the other equation is to see something that has a coefficient of 1. So the x in the second equation has a coefficient of 1. So that means we can just multiply the second equation by negative 2, and that will give us a form that will make the x's go away. So we write the first equation, which is 2x minus 3y equals 4. We're going to multiply each term in the second equation by -2, which is totally legal because they told us in algebra over and over that if I multiply one side of an equation by a number, all I have to do is multiply the other side of the equation by the same number, and we will have an equal statement. So -2 times x is going to give me -2x. -2 times positive 4y is going to give me -8y. And -2 times -9 is going to give me positive 18. So then we line them up. We have -2x minus 8y equals 18 for the second equation. Add those together, down the columns again, the x's disappear. -3y minus 8y gives me -11y. 4 plus 18 is 22. Okay, so this is going to give me this particular result, -11y equals 22. Divide both sides by the -11, and y is equal to -2. Okay, so once again, that's half of our solution. So now we're going to take the -2, and plug it back into one of the two original equations. Okay, so what I did here is I picked the first equation, so I took 2x minus 3 times -2 that I substituted in for the y is equal to 4. Multiply out, which is going to give us 2x plus 6 equals 4. Subtract the 6 from both sides, gives us 2x is equal to -2. Divide both sides by the 2, gives us x is equal to -1. Okay, so our solution here is going to be the point -1, -2. Okay, once again, it's written as coordinates because that's what it represents. It's the coordinates of the point where those two lines will cross each other. Okay, example 3. Okay, this time we're going to use the substitution method. What you're always looking for in the substitution method is to see if one of the variables has already been solved for. In this case, the first equation says y equals 3x plus 4. What this means is any place in this other equation that I see a y, I can put 3x plus 4 in its place. So we rewrite the second equation as x minus y equals 2. Okay, we're going to substitute the 3x plus 4 in where the y is. So here comes our other equation, and notice that it has the 3x plus 4 replacing the y. Okay, so now it becomes x minus 3x minus 4 equals 2 because I distributed the -1 that's in front of the parentheses across the parentheses. Okay, combine the like terms gives me -2x minus 4 equals 2. Add the 4 to both sides gives me -2x is equal to 6. Then I divide both sides by the -2. Which gives me x equals -3. Okay, so that's part of our solution. So I'm going to take the -3 and I'm going to plug it back into one of the original equations. Okay, so I picked on the first equation, so it's going to become y equals 3 times -3 that was substituted in for the x plus 4. Okay. 3 times -3 is -9, so this becomes y equals -9 plus 4. Add those together gives me y is equal to -5. So once again, our solution is a point that has the coordinates -3, -5. That's where these two lines will cross each other. Okay, example 4. They want us to use the substitution method for this. Notice this one's a little bit more complicated because they did not give us the x is equal to something or the y is equal to something. So we can't just substitute directly. So we're going to have to solve one of these equations for either x or y. In this case, once again, I'm going to look and see if I have a +1 for one of my variable coefficients, in this case the x. So that means I can solve for x in the first equation simply by moving the -3y to the other side of the equation, which is going to give me x equals +3y plus 4. So now I can substitute this 3y plus 4 into the second equation where x is. So that's going to be rewritten right here, and it's going to be rewritten this way. 2 parentheses 3y plus 4, which took the place of the x, plus 7y equals negative 5. Okay, do the distribution. That's going to give me 6y plus 8 plus 7y equals negative 5. Combine the like terms, so that I'm going to add the 6y and the 7y. That gives me 13y plus 8 equals negative 5. I'm going to subtract the 8 from both sides. Gives me 13y equals negative 13. So I divide that out, so y is equal to negative 1. So there's part of my solution. So the next thing I'm going to do is I'm going to take the negative 1, plug it back into one of the equations. I think I used the first one. So substitute negative 1 for y. So I did use the first one, so this is what I've got. X minus 3 times negative 1, where the y is, equals 4. Do the distribution, gives me x plus 3 equals 4. Subtract the 3 from both sides. That gives me x equals 1. Okay, so my solution to this, or the point where these two lines are going to cross, has the coordinates 1, negative 1. Okay, that completes this lesson. Once again, if you have any questions about this, any complications or anything that you want to have cleared up, just bring them to class tomorrow, either on your notes or it's in your head, whichever the case is. Raise your hand or put a post-it on the parking lot, and we will answer the question before we start. Thank you very much. Goodbye.